Let's talk about some basic concepts of probability. So when we're talking about probability, usually we're talking about a random experiment. So a random experiment is a mechanism that produces a definite outcome that cannot be predicted with certainty. An example of a random experiment like this might be flipping a coin. So that's an experiment that produces a definite outcome. So either a heads is going to land up or a tails, but we cannot predict the results with certainty. It's either going to be one or the other. We never know what's going to be flipped until we flip it. And the sample space associated with that experiment is just the set of all possible outcomes. Because when we're finding probability of events, it's helpful to find the sample space first so that we can look at all the different types of possible outcomes. So for example, for flipping a coin, we could, and I'm going to use a curly bracket because when we write out sample spaces, we use curly brackets. And I'd say the sample space for flipping a coin would be H, comma, T, which means heads, comma, tails. So this is how you would write out the sample space for flipping one coin. And you could write it out in words too, HEADS, or you could abbreviate. And so that's the sample space for flipping a coin. An event is just a subset of a sample space. So for example, heads, that's an event, or flipping tails, that's an event. And it's one of those events is going to occur on a particular trial of the experiment. So for example, you might, and comes in handy when you're asking probability questions. So for example, what's the probability of flipping a head, or what's the probability of flipping a tail? So theoretical probability, if we say E to be the set of outcomes of some experiment, then the probability of an outcome in E is a number P between 0 and 1 that just measures the likelihood that that element occurs on a single trial. So for example, let's just think of this flipping a coin example. If you have two choices, you can either flip heads or tails, the theoretical probability of flipping a head is going to be a number between 0 and 1. 0 means there's no chance of it happening. 1 represents 100% chance of it happening. In this case, the probability of flipping a head is going to be 1/2 because there are two possibilities and one of them is a head. So the probability of flipping a head is 1/2, or we could say 0.5, or we could also say 50%. And one way that we could write this, as it says in this paragraph, is that we can denote it using this notation P, parentheses, and then whatever the event is. So an abbreviation might be, what's the probability of flipping a head? And we'd write it like this, P parenthesis H, and you would say probability of flipping a head is 1/2 is how you would write it. In our course, for theoretical probability, we'll only consider experiments where each outcome is equally likely to occur. Okay, and so this box below, this just goes over the probability formula for an event, and I already just used this formula when I calculated the probability of 1/2. And so let's kind of go through this. So basically, all you have to do if you want to find the probability is you have to take the number of outcomes for the event. So meaning, like, if I wanted to find the probability of flipping a head, I look in the sample space and I see, well, how many heads are there? Well, there's only one, and the bottom, the denominator, represents the number of outcomes in the entire sample space. So that's like the total possibilities. You could think of the bottom or the denominator like that. And so there are two possibilities for how you could flip a coin, and the number of heads that goes in the numerator, there are one head options on a coin, and so the probability is 1 out of 2. And what we can do, let me just zoom back out so we can see the percent chance part. What we can do is we can also think about this as a percent chance. So if we convert the probability to a decimal, so 1/2 converts to a decimal of 0.5, and then we can convert it to a percentage of 50%, we could call this the percent chance. So the percent chance that you would land on a head when flipping a coin would be 50%. Let's do an example. So we're going to do an example where we consider the experiment to be rolling a 6-sided die once. And we're going to find the probability of the event rolling an even number. So the experiment in words, like if we were to write it out, we would write rolling a 6-sided die once. And so the sample space is just the list of all possible outcomes in S, and we write this as a set, so we use curly brackets. So if we have a 6-sided die, our options are 1, 2, 3, 4, 5, and 6. And the event, so not the experiment, but the event, like what we're trying to find the probability for in words, is rolling an even number. So we're trying to find the probability of rolling an even number. The subset of the sample space that represents this event, so that would be all of the even numbers, would be 2, 4, and 6. So 2, 4, and 6 are all the even numbers. And so we can recall from set theory, the notation for n parentheses S just means the number of elements in S, or in this case, the number of outcomes in S. And so S is our sample space. So there are 6 different outcomes in our sample space, and there are 3 even numbers, so 3 numbers or outcomes in E. Therefore, if we want to find the probability, we just do 3 divided by 6. And I could just write this out even further. So this is the number of even numbers, and this is the total outcomes in the sample space. So 3 out of 6. And then we can reduce that by dividing both of these by 3, and we end up getting 1/2. If you want on your TI 34 and 30, if you use the fraction button, you can punch in 3 divided by 6 in case you have difficulty reducing by hand. You can use this calculator to reduce, and you can just hit the simplify button and hit enter, and you're going to keep doing it until you see the factor of 1. Now notice when I did it a second time, I didn't get any other result, but it's always good practice just to keep hitting that button until you see a factor of 1. This just means that it divided it until it divided by a common factor, and in this case the only other common factor is 1. So you know that you're getting it to the lowest term. So 1/2 would be the answer to that problem. Okay, so let's look at theoretical probability example 2. So we're going to look at the same experiment, rolling a 6-sided die once. So A, list the sample space S for this experiment. So the sample space is the same as what we were working with before. So we have a 1, 2, 3, 4, 5, or a 6. So those are the possibilities. Identify n sub s, so that just means how many elements are in there. So there are 6 different possibilities for rolling a 6-sided die. Find the probability of rolling a 2. Well, a 2 is one of those outcomes, so we can say 1 out of 6. So we could also list out our event, in this case, is rolling a 2, and the number of elements in that event is 1. This is the way that you can, using set notation, to write out basically that there is 1 outcome that represents rolling a 2 and 6 total. So the answer is 1/6. For C, what's the probability of rolling a number less than 5? And so we can just identify, well, how many numbers are there less than 5? Well, there are 1, 2, 3, 4. Less than 5 doesn't include 5. So there are 4 outcomes that represent numbers less than 5, and there are 6 total outcomes. So the bottom represents the total in the sample space, and 4 represents the number of numbers less than 5. Okay, and then we can reduce this by dividing both of these by 2. And if we do that, we end up getting 2/3. Okay, and so then I'm just going to go ahead and erase those red lines because we've got a new problem now. So what's the probability of rolling a 3 or an even number? So my denominator is still 6 because remember that's the total possibilities, and a 3 or an even, let's go ahead and count. So I'm going to go through and I'm going to count, okay, every single time we have a 3 or an even number. So this is even, this is 3, this is even, this is neither, so I don't count it, this is even. So I counted all of my even or 3s and I end up getting 4. And so that also amounts to 4 out of 6. And so just like we had before, that reduces to 2/3. Probability of rolling a 7. So, and let me go ahead and erase these guys here. So I've got my same total, so there are 6 possibilities, and I look and see, well, how many of them are a 7? 0, none of them. So it's totally possible to have a probability of 0 out of something. And if we divide 0 by anything, you just get 0. So there is a 0 possibility or probability that you're going to roll a 7 on a 6-sided die. And then lastly, so what's the probability of rolling a number greater than 0? So out of 6, let's go ahead and count. How many of these represent an outcome greater than 0? Well, 1 is greater than 0, so is 2, so is 3, so is 4, so is 5, so is 6. So all of them are greater than 0. So 6 out of 6, or 1 if we reduce, is the probability of rolling a number greater than 0. And then remember, we talked about how we could express this as a percent chance. With any of these, you can find the decimal and then move the decimal 2 spots right. If we do that with 1, the decimal is here. You can just move it 2 spots to the right or multiply by 100. So the number 1 as a probability just represents a 100% chance of it happening, which we know there's a 100% chance that you're going to roll a number greater than 0 on a 6-sided die. For theoretical probability example 3, we're going to look at the experiment of tossing 2 coins. Okay, so let's start by listing out the sample space and then we'll identify how many elements are in that sample space. So if we flip a coin, if we flip 2 coins, what could happen? Well, we could get a head and a head, we could get a head and a tail, we could get a tail and a head, or we could get 2 tails. So the number of elements in S, which is what this notation represents, is 4. There are 4 elements in the sample space. So when we're asked to find the probability, right off the bat, you can make a fraction and just put a 4 on the bottom. And so this first one, what's the probability of getting 2 heads? Well, you could look at your sample space and there's only one outcome where that happens. So there's a 1/4 chance that you get 2 heads. What's the probability of getting at least 1 head? So at least means you could get 1 or 2. So really you're just counting anything with an H, and so I would count those 3. And so I would say that there's a 3/4 chance of getting 1 head. The probability that you get the same thing, so that would be either a head or a tail, that would be what this event is referring to. So there are 2 options there. So there's a 2/4 probability, or you could divide those both by 2 and simplify and get a 1/2 probability of that happening. Okay, so let's check out some probability facts. These can be really helpful just to guide you in doing these probability problems. So probabilities are always between 0 and 1, and you can see that on the number line below. This is really nice because when you're doing these probability questions, if you ever get an answer that's not between 0 and 1, then you know you did something wrong. And so when we think about, let's think about weather. So if I ask you, what's the chance that it's going to rain today? You could say, well, there's a 0% chance. That would correspond with 0 here. 0% chance. That means it's impossible. Now we all know with rain, nothing's impossible. So even if we say there's a 0% chance, the weather person could be wrong. But that 0%, that's really what it means. It's impossible. If there is a 100% chance of something happening, that corresponds with the decimal equivalent of 1. And that means certain. It absolutely is going to happen. And anything above that doesn't make sense. So to say that there's a 200% chance of something happening doesn't make sense because 100% means it's it's going to happen. So you really doesn't make sense to use a number greater than 100% or greater than 1. And same for less than 0 either. To have a negative percent chance or a negative probability doesn't make any sense. And then you can have numbers in the middle. So a 0.5, that's like a 50% chance. You could say, you know, over here, this would be the decimal point 75, which would be like a 75% chance. So maybe we could use a word like likely there. It's maybe likely to happen. Over here, you could put a decimal like 0.25 or 25%. That would be something we could say is unlikely. So somewhere in this scale is where your probability should land always. The other fact, the sum of all the probabilities and the outcomes in the sample space will equal 1. Let's check out this coin example above. So our sample space, we could do a head, 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 tails, tails, head, or tails, tails. If we look at the probabilities of each, so the probability that you get a head, head is just 1/4 because it's 1 out of 4. The probability of heads, tails is 1/4 because that's 1 outcome out of 4. Probability of tails, heads is 1/4. And the probability of tails, tails is 1 out of 4. So when you think about those, if we add those all together, we end up getting 4 out of 4 or just 1. And that's all this is saying, is that the probabilities in the sample space are always going to equal 1. This next one is really handy. So for any event, the probability of, remember the apostrophe is a complement or it not happening. So the probability of the complement of the event is just 1 minus the probability of the event. And so, for example, if I said the probability that it's going to rain tomorrow is 0.30, so that's like 30%, then the probability that it's not going to rain is just going to be 1 minus the probability that it's going to rain. So we could take 1 minus 0.30 and get 0.70. So that basically means that there's a 30% chance that it's going to rain, and there's a 70% chance that it's not going to rain. So my guess is intuitively this probably made sense before you even looked at this formula. So just something to think about, and we'll do some examples later on. And so hopefully this scale and these probability facts will help you when you do your probability problems.